All right, we're looking at V6, which is multiplication and division with exponents. Our instructions say simplify, so we're going to come up with one answer, and we're to express our answer using positive exponents. So we have n to the negative 7th multiplied by n to the negative 9th multiplied by n to the 2nd. So our multiplication rule says that we keep the base and add the exponents. So we've got n, which is our base, negative 7 plus negative 9 plus 2. Well, negative 7 plus negative 9 is negative 16. Negative 16 add 2 is negative 14, so that would be n to the negative 14th. But again, we're writing these as positive exponents, so we have to flip this over, and that gives us n to the 14th under 1. So 1 over n to the 14th power is our answer. Look at number 2. We have k to the negative 6 times k to the 6th times k to the negative 9th. Keep our base, add our exponents, so negative 6 plus 6 plus negative 9. So negative 6 plus 6, that's 0. So we end up with k to the negative 9th. You know we can't have that, so flip it over, and we've got 1 over k to the 9th. Number 3, you've got z to the 6th times z to the 4th divided by z to the negative 2nd power. Now, when you have a combination of multiplication and division, I want you to make note that the division bar right here is a grouping symbol. It means first, do everything on top. And then divide. So what does that look like? So I've got z to the 6th multiplied by z to the 4th. We know that's z to the 10th. Then we're going to divide by z to the negative 2. Now, at this point, I could say z to the 10th minus negative 2. I know I'm adding those, so my answer would be z to the 12th. And if you didn't quite catch that, rewind it. Look at it one more time. All right, here's number 4. We've got p to the 4th, and then p to the negative 5th times p to the 5th. So we're going to do, this time, we're going to do everything on the bottom because that's where the multiplication is. So I guess I could have said up here, do everything on top, or multiply first. Because as we can see, it may not always be on the top, it could be on the bottom. So we've got p to the 4th divided by p to the negative 5th plus 5. Well, we know that as p to the 4th divided by, well, negative 5 plus 5 is 0, so p to the 0 power. We know that as p to the 4th power divided by 1, and 1 divided into anything is just that number, so our answer would be p to the 4th power. All right, let's look at number 5. We've got w to the 0 power times w to the 23rd power times w, and we know there's an imaginary 1 there, so to the 1st power. W to the 0 power is 1, multiplied by W to the 23rd plus 1, because we're keeping our base, which is W. And so that would be 1 multiplied by W to the 24th power, which is equal to W to the 24th power. All right, I had to flip over to another page because I ran out of room. So we're doing V6 continued. Here are the rules. If we're multiplying, we're going to keep the base and add the exponents. If we're dividing, we're going to keep the base and subtract the exponents. If we have both multiplication and division in the same problem, do the multiplication first and then divide. All right, so question number 6 is k to the negative 1 multiplied by k to the negative 1 multiplied by k to the 7th. Keep the base, which is k, add the exponent, so negative 1 plus negative 1 plus 7. So negative 1 plus negative 1 is negative 2, and negative 2 plus 7 is positive 5. So our answer would be k to the 5th power. Number 7 is r to the 66 times r to the negative 1. We're multiplying, so we're going to add our exponents and keep the base. So we've got 66 plus 1 plus negative 1. Well, 1 plus negative 1, those cancel out, so I'm left with r to the 66th power. Number 8 is w to the negative 86 times w divided by w to the negative 1st times w to the negative 9th. Now remember I said when we have both, we're going to do multiplication first and then divide. So here we have w, keep the base, negative 86 plus 1 gives us w to the negative 85th power. And here we have w to the negative 1 plus negative 9. That gives us w to the negative 10th power. Now we take our w to the negative 85, and we're going to subtract negative 10, which means basically we're adding 10. And that would give us scooch it over. I'm so sorry. I get so involved in looking down, I forget to look up at the screen to see if you can see. So that would be w to the negative 75th power. We know we have to flip that over. So that becomes 1 over w to the 75th power. Now there were a lot of steps in that one, so you may want to go back and watch it again. For number 9, we have k to the 6th multiplied by k to the 54th divided by k to the 83rd multiplied by k to the imaginary 1. So we've got keep the base, add the exponents on the top, keep the base, add the exponents on the bottom. That leaves us with k to the 60th power divided by k to the 84th power. Now when we do that, we end up with k to the 60th power minus 84. That gives us k to the negative 24, because 60 minus 84 would be negative 24, or you can flip those around and do 80 minus 60, which is 24, and the 24 gets the negative because 84 is the largest number and it's negative. So again, we have to give our answer as a positive exponent, so we're going to flip this over and we end up with 1k over 24. All right, we'll make this the last one that we do together. So number 10, I'm going to scoot this up. We've got y to the 5th divided by y to the 4th multiplied by y to the negative 51 multiplied by y to the negative 1. So we've got y to the 5th, that stays the same, but on the bottom we've got to add all these exponents. So y to the 4th plus negative 51 plus negative 1. So that turns out to be y to the 5th over, well, negative 51 plus negative 1 is negative 52. And then we've got positive 4. So if we take 52 and we subtract 4, that would give us 48. And we know that it would be a negative 48 because 52 is larger and it's negative. So now we have a situation where we have a positive exponent in the top and a negative exponent in the bottom, or the denominator. Here, you're not going to flip this over, because if you did, then the 5 would become negative, although the 48 would become positive. You leave the positive where it is. So your answer then would be y to the 5th power multiplied by y to the 48th power. Now you have a multiplication problem again. Or I could have written this like this, just so that you see what I'm doing. Keep the base, subtract the exponents, right? That's what I did, and this becomes plus. So this is the same thing as that. So y, 5 plus 48 is 53. So our answer would be y to the 53rd power. I'll do one more because these can get really, really interesting, and I don't want you to feel like you're not prepared to do them. So we'll make this one the last one, I promise. So y to the 5th power times, I said y, I meant v, to the 88th power, right? And then we have y to, I keep saying y, v to the 5th power multiplied by v to the negative 5th power. So we're going to do the multiplication part first. So we've got, keep the base, v, add the exponents. We've got 5 plus 88, which is 93. Then on the bottom, we've got 5 plus negative 5, which we know is 0, because that's the same as saying 5 minus 5. So we've got v to the 0 power, and we know that would be v to the 93rd power over 1. Well, any term divided by 1 is itself, so our answer would just be v to the 93rd power. All right, should I do this one? I guess I should. I never know what's going to come up next, so I keep saying this is the last one, I promise. But if I see one that I think bears that we should do together, then I'm going to do it. Even if I said, this is the last one, I promise. Because you may need help on this. So we've got f to the 5th power, g, h to the negative 1. We're multiplying that by f to the 7th power, g to the negative 3rd power, h to the 4th power. Multiplying that by f to the 8th power, g to the 6th power, and h to the 2nd power. Just group them. So you're going to have f to the 5th, find all your f's, plus 7 plus 8. Then do all your g's. So g to the 1st plus the negative 3rd plus 6. Then h would be to the negative 1 plus 4 plus 2. So 5 plus 7 is 12 plus 8 is 20. So this would be f to the 20th power. And then g is 1 minus 3 is negative 2 Negative 2 plus 6 is positive 4, so that would be g to the fourth power. And then h is negative 1 plus 4, which is positive 3. Positive 3 plus 2 is 5. So our answer would be f to the 20th power g, whoops, to the fourth power and then h to the fifth power. And I'm stopping there. Really. So if you need any help on this, please attend tutoring or don't be afraid to ask. See you later. Bye-bye.